Alright guys, got it cooled down. And I put it in a 5C collet, a 1/2 inch collet. Come on, baby. And I faced it off a little bit. And I put a center point in it. So you can see in the middle the steel surrounded by all the braze, the bronze. I don't know. I could just look at this for a while, man. This thing is just so cool looking. But there she is. And it's running nice and true. I mean, it didn't wobble at all. And it doesn't matter because I have to... so, let me kind of get this situated. So this is 15/16. This is 0.938 the whole way. Just under an inch. I need to machine it for a thrust bearing. So I'm going to leave this, I might leave, I don't know, 3/16, maybe 1/4 inch of a lip of that diameter that it is right now, which is almost an inch, and turn it down to 3/4 the whole way, right? That way, I can use the 3/4 thrust bearing. This thing does not focus. I can use the 3/4 thrust bearing. I'll put it next to the shaft. And we will talk about it. So, the thrust bearing that came off of this one is that, right? It's a 3-piece bearing. I need to... oh, come on, get on there. Where's that one? Maybe it was this one. Yeah. So, pretend that that's a thrust bearing. The balls are missing, right? I'm going to have to get balls or a different one, but you get the idea. So that little step, that step right there is needed right there. So I'm going to leave this parent material, which is 15/16, almost an inch. Turn it down to 3/4, and I think this, I don't know what this thrust bearing is. It's too small. I mean, it's like 5/8 or it's like point. I don't know what it is. It's some weird size. And I don't want to thin this too much because I will be getting into my braze and weakening the end. But if I take this down to 3/4, it'll still be plenty strong. And do I need to cut a knob, threads, and a key for my handle? Oh, let's see here. This is the original handle. So that's a 7/16 bore. And there's no way I can use this. It's not big enough. Because I want to, like I said, go with a bigger. I don't want to, because I attach this here, I don't want to go too much smaller. I mean, it's, you know, it's down to, it was actually a little less than 3/4 that so I didn't pocket that in there 3/4. It was 21/32 or something. It was 0.653 or something. 0.6, call it 0.65. So if my pocket full of braze, pocket full of kryptonite, baby, my pocket of braze in there is 0.65, and the steel starts beyond that. If I cut the steel to 0.75, that's 100 thousandths difference. That's 50 thousandths wall of steel encasing the braze. I'm thinking that's going to be strong enough. I think. I don't know. This is an idea. I don't know if it's the best idea. I could, instead of going to 3/4, I could go to 7/8. I don't know. Look at the hand wheels I got. But anyways, we're making progress. I wanted to just document what I got finished up here with this today. And I guess I'll show you more. Alright, well, I have a bunch of bearings in stock. This is a thrust bearing, a nice one, a ball thrust bearing. It's 7/8. So if this is 15/16, right? Then you know, I've got a 1/16 difference, so that's like 30 thousandths perimeter all the way around would be the step. So basically this would fit on here, and I'd have to turn this down 30 thousandths in order to make it 7/8, and going from 7/8 to 15/16, you know, that's a 1/16. Half of a 1/16 is a 32nd. A 32nd is 0.031, so call it 30 thousandths. So I'd have a 30 thousandths change in step just to retain this. I think it'll never jump over a 30 thousandth step. It's not ideal, but I'm not pushing the world either. You know? And then that's less meat I have to take off of here. Not that I'm super concerned about it, but the thicker the better. And I've got plenty of room in my tailstock, right? I have not decided if I'm going to use the old butt end of this or not. It looks kind of beautiful. It does look nice on there, but I'd need to make something to screw into, right? So what I was going to do is I got this piece. This is 600 wide, and I surface grounded on both sides. I left a little bandsaw blemish there, but that's just nothing. So I was going to turn this hockey puck to fit inside. I'm going to waste a little material, but that's not too bad. I'm going to turn to fit inside, then I'm going to put 4 quarter 20 screws around the perimeter. Maybe I got some, you know, dome head or button head, you know, nice screws around the perimeter. And then I could thread this. This is 1 5/8 16, right? So you know how you tell. So this is 3/8 16, right? I mean, this is just so basic. Is that the, yeah. You just take it. There you go. See that? 16 is 16 is 16. 3/8 16 or 1 5/8 16. Oops, doesn't matter. That's how you tell, you know, really quick, instead of getting out the stupid pitch gauges. But that does look sexy, I gotta tell you. So if I put that in there, and then internal thread that piece, and then screw that in there, and then that's 7/16. I'd have to open that up to what did I say? 7/8 shaft, which is no problem. I think that's about 7/8 there. That protruding boss, the raised boss, would be pretty much gone, and then the shaft would come out. But then this is the bearing for the radial thrust. See, it was just a steel bearing, and it had a slot for the oil. The oil would come from that button oiler. So I could leave it steel on steel like Hendey did, and it lasted 100 years. Or sleeve it with bronze sleeve. Oh, I got maybe some oilite. I don't know. Or just forget this thing, put the thrust bearing on the back and put a bronze in this, and it would just be a flat ended tailstock, which I don't think would look bad either. I think it's more farting around to do a threaded thing instead of just doing it native into that. Even though that is a sexy rounded, you know, butt plug for the tailstock. Kind of nice. Either way, alright, those are my options, but where did I set down my thrust bearing? I'm thinking about using that thrust bearing, wherever the heck I set it down. Because, you know, actually I've got a few. Man, look at these. I got freaking thrust bearings like crazy. Here's another one. Here's bushings. I mean, I got all kinds. I got all kinds, dude. Alright. Alright, we'll bring you back. Just wanted to show you my thoughts on the thrust bearing. Alright, I'm thinking maybe on this one, right? How big is this thing? This is 8 inches. That's 4 to the center. 8-inch diameter. And it's aluminum. And, you know, trying to keep weight down, this could easily be bored to 7/8. The thickness is about 1.25 inches, so that's not too terrible. I like this because it's light. And you know, if I wanted to, I could turn that centered thingy thing. You know, I could get in there with a hacksaw or a jigsaw or a grinder and a file, and just make it look like with the spokes without the center donut thing, whatever that is. So that's not too bad, and I want to keep the weight down because I'm adding a bunch of extra weight anyways to this tailstock, and just kind of balance it there. Stay, bastard. Yeah, come on now. Alright. Yeah, shit's in the way. It's a little above center, but you know, there's no base on this yet. I think that might be cool. I mean, this has got a substantial handle to it. You know, it's kind of a. I like the substantial handles, and because I'm making it longer, like I said, I mean, right, it'll be out there. I mean, right, it'll have that extension on it, but. I got 3 of these. I got an 8. This is the 8. I got I believe a 6 and a 5. You know? I don't know. But that's a definite maybe. Alright, well, 8-inch aluminum tailstock wheel. We'll think about it. Bring it back. Alright guys, Been doing some machining on that Acme screw. I'm over here on the mighty Pratt & Whitney lathe. And got the indicator out and all this good stuff, right? So let me show you what I got. This is the shaft. I got it chucked in the collet in the 5C collet closer, and I've been using the tailstock for support. Turn this lamp off. All right. What I got is, I hope you can see this. This is 7/8 and this is 15/16. So it's a 16th difference in diameter, so that leaves a 32nd on the radius, or 30 thou, 31 thou. So what I got is this thrust bearing, which sits on a 7/8 shaft, and it's got a bit of a bevel of a lead-in. I was wondering if this was going to be enough. I slept on it last night, you know, and 30 thousandths all the way around, you know, a 16th in diameter. That's going to be fine. Let me try to zoom in without farting up the works here with the focus. Maybe it's better. Let's try the lamp. Maybe. But now that lamp is terrible. Give the camera a second to adjust. But it's not going to go over a 30 thousandths jump. You know, it's not. And, you know, with this brass sleeve for it actually goes inside the brass sleeve and registers on the race. So I could run this either way if I wanted to, but that's it's gonna work. It's gonna work, man. So now I need to put a 7/8 hole, maybe a bushing, a bronze bushing in that hockey puck piece. And my handle, I think I'm going to use a clamp collar, a 7/8 clamp collar, and affix the handle to that with 2 1/4-20 screws or something. But that's what I got, man. Things looking minty, as the young kids say. Alright, we'll machine more and bring you back. Alright guys, I hope this film's okay. Hello. I got this piece of steel in here. I think it's about three or so inches, and what I need to do is I'm making the butt end of this tailstock, you know, so I need this to fit inside that tube, and the tube, the bore of the tube is 2 1/8, and I got it in the Sagami chucker here, and I got it in the 4-jaw, and you know, I was thinking, how do I take this down? I thought I could take, I'm halfway out the jaws here. I figure I could turn half of it down to 2 1/8, flip it over, and you know, turn it down again to 2 1/8. I thought that might be fiddly, you know, hard to get it not to wobble in the chuck. So this is running within less than a thou on the radial and on the axial on the face. What I'm going to do is I'm going to center drill it, drill it with a 1/2-inch drill bit, and I think bore it for this 5/8 dowel pin. Then I can press fit this 5/8 dowel pin and use it as a temporary mandrel, and then take the outside down to 2 1/8 so it fits in my tube properly, and then push the pin out and bore for my bushing for that handy dandy Acme lead screw. So let's start the process and talk less. Here we go. This lathe runs so smooth. Now this turret, there's a stop on the cross slide that allows this chuck to be on 0. Steel's got a little hardness to it when I drill. Oh, it's not bad. So this lathe has a brake, and it also has a screw-on chuck. So I turn the brake off when I use a screw-on chuck. I only use the brake for collet work, where there's no inertia problem. So here's my 1/2" bit. You know what? Let's blow through this. This is a carbide, I think it's 218. Center cutting, carbide .218. What was that? 7/32 or something. This drill's easier than the center. Sorry, this drill's easier than the center drill. It's amazing. All right, so get all that material out of there. I think this is 1045. I really don't know because it was in the dumpster, but I believe it's 1045. Slow the lathe down. Instant, infinite variable speed. Two beautiful, equal chips. Maybe you can see that. Beautiful, equal chips. This is like a barbecue sauce brush that I got at the supermarket, and I've been using it for years as a chip brush. I glued the bristles in, I think at least twice with wood glue, but now it seems to be holding up just fine, right? A 1/2" stubby, I keep this by the lathe because it's good for coring out, doing exactly what I'm doing. Watch my drill doctor video, my Derek's drill doctor video. I fixed it. It progressively got more and more crappy over the years. I'm gonna go with a conventional boring bar. Let's do a 5 thou cleanup. Touch off. Ish. Creeping up. Listening for the rub. There's the rub. So here, let's go 5 thou. See what it'll do. Just for fun with the channel. All right. 7 more, but there's 6. 7. 7. I'm a solid 7, but I really should take 5. It's got some tool pressure, I think. not too bad. Let's do 5. And now, before I retract it, I'll pull it back. So my dial's at 125. So, because this carriage is a dovetail bed like a Harding, and it's got some wear in the dovetails, it crabs, okay? So, what I mean when I say it crabs, if you're turning the outside and you reverse the carriage, it pulls the tool away. If you're boring on the inside and you retract the tool, it digs in deeper. That's what crab is. It's where the pinion wheel is on the rack in relation to the edge of the bed. So now that it's stopped, I'm not going to touch the dial. I'm just going to pull out. And it probably left a lining there from the tool bit, but I don't care. I'm at 3 thousandths to go. 3 thousandths. Which is probably way too heavy of a press fit. Right? It wants to go, Johnny. No. Actually, that probably would go. And granted, I'm not, you know, this is not the right thing for that. Let me, off camera, walk over to my little area here. 5/8 to... So we got this guy, right? It's the, I hope you can see that. You probably can't. You know what these are. Little inner and we're going to measure this. It says 3 thou also, or does it? I know I should be using we can see that. It says 1 thou. It's a good thing I measure with this. Let me swipe it again. So you kind of find the center, crook it off center, tighten it, you know, some magical amount, and let me grab the good old caliper. And I suck at measuring with the mic. I said grab the caliper, I meant grab the mic. It's a micrometer caliper, right? And I am not the guy. I usually use the super mic on the windowsill. No, this is totally wrong. I screwed this up. It's not right. I'm reading 2 thou under. So you wiggle it, you pressure it, you wiggle it once through. Oh no, it's going to be under. That's no, what the heck? I'm reading under. I'm thinking I'm going to be over. I'm reading 3 thou under. I'm reading 23, 22 and a half. 22, 22 and a half. One more time. I didn't like that. $22 and a half. So 23 and a half, 24 and a half, and then 25. I'm 2 and a half thou. That's a lot. I mean, let me just go in here again without advancing. Let me go 1 thou. You need a really sharp carbide insert or tool bit to take a thou. This one's pretty sharp. Positive rake. Alright, again, turn it off. Yank it out. You know, this is what you do. Stick your finger in there. Clean out the dust. Okay, so I got the spring going. I kind of found the center. I lightly tension that. I'm wiggling it as I break it over center. And then I get this guy. And I kind of hold it with 5 hands. So there's 65. So I'm 23 and a half. So 24 and a half. So I'm a thou and a half press fit. With that dowel pin, which I set down and I can no longer, there it is. So I'm a thou and a half press fit. Yeah. That's pretty good. A thou and a half will go in there nicely. Either end. The chamfer is a little weird. I'm going to use the rounded end. Okay. We're going to loosen this one. And then loosen the one next to it. See, these aren't super tight. I just got them nipped up just enough. So these top 2 are what I tightened. You want to watch me press it in? Sure, let's go.